All right, number 18. You've got dy dx equals 3 minus x over y. Now, part A is a little odd. No, part A, we're not solving this. So we're not solving this, we're not finding the particular solution. Part B, we are. Okay? Part A, we are looking for, what are we looking for? We're looking for whether we have a max or a min at a certain point. So this one's a little odd. It says that, what does it say? That the line y equals negative 2 is tangent to the graph. So here's the graph. If I go down 2, y equals negative 2 is this line, right?
Yeah.
You guys okay with that? That is the tangent line to whatever y is. Now, we're not going to solve for y right now, but that's the tangent line for whatever y is. So what does that mean y looks like? It could be a parabola. It could look like this. It could look like that, or it could look like this, or I'll just do it over here. It could look like this, right? It could look like a bunch of things. But if this line is a tangent line, what kind of tangent line do we have? A horizontal tangent, which means what? The slope of the curve is 0. So what can I say here? 0 equals 3 minus x over y. We'll get there. Okay. Are we okay with that so far? So we're saying that this line has a 0 slope. dy dx would then be 0. The slope is 0. When, though? Right. At this point or with this point, whatever point is, the bottom line is, what is this coordinate? It's x comma y, right? What's the y value there? It's negative 2. So we just plug in negative 2 to that. And then we solve this, so we get 0 equals 3 minus x. So x equals 3. That's the first part. It says find the x-coordinate at the point of tangency. So that's the point of tangency. If I plug in 3 comma negative 2, 3 minus 3 is 0, over negative 2 is 0. That means the slope, the derivative is 0. And therefore, that's the 0 slope at negative 2. Are we okay with that part?
Yeah.
Okay. The second part says, determine whether it's a local max, a local min, or neither. How do you know if a point is a local max or min? What's that? What about the derivative, though? Local max means the derivative, f prime, changes from positive to negative, right?
Do we have to write that?
No, you don't have to write this down. I'm just showing you the connection here, okay? Local min is the opposite, right? Local min is when f prime of x changes from negative to positive. And neither would imply what? That means
It touches it.
f prime
Gives it.
like this.
Oh.
Is this a max or a min? No, it's because f prime is what? Strictly
Positive.
positive or strictly negative. It didn't change signs. So local max is okay. So we've got to look at f prime. We got to look. This is f prime, isn't it?
Wait, does it change signs on that?
Well, why is f prime? What?
It takes out changing signs on that.
Yeah. Is it doing this? Now, normally you get something like this. Y prime equals x minus 2, for example. You would know this is a max or a min because you would set this equal to 0, which we already did all that. We got x equals 2. We did that. Then what do? You do a number line at x equals 2, right? And then you pick a number to the left, so like 0, so you get negative. Pick a number to the right, like 4, you get positive. So therefore, this is a minimum. The problem is we've got a y in this equation. So this makes it more complicated. Yeah.
That's the graph of dy dx.
No, this is the graph of y.
That's the graph of y.
This is the graph of the tangent line, and then these are just possible answers. They're not the actual graph. Now, we talked about this briefly. we have two options. This option is called the first derivative test. The first derivative test because you're using the first derivative to determine extrema, right? There is a second derivative test. We did talk about that. Okay? And this usually pops up on the AP exam about every other year. Okay? I don't know. I didn't take the AP exam. I don't know. You're not supposed to discuss. All right. So second derivative test says this. What do we know about the second derivative of this? It's positive because this is concave up. What's the second derivative here? Negative. So what is this point in this curve? It's a what? Is that a min or a max? It's a minimum because it's concave up. It's a maximum because it's concave down. What's going on here? What's that called? It changes concavity, called a point of inflection. So what is the second derivative at that point? It's 0, but it's negative on this side, positive on that side, so it's nothing, right? So here's what the second derivative test says. First of all, what does f prime have to equal? What does the slope have to be at these points? 0. So the first part is this. Number 1, dy dx equals 0. And number 2, you have d2y over dx squared. What's that mean? Just second derivative. If the second derivative is greater than 0, then this produces a what? This would imply what? Concave up, therefore relative min. If it's the other way, where dy dx still has to equal 0, and d2y over dx squared, second derivative, is less than 0, that would imply relative maximum. The function is concave down and 0 at that point, therefore it's a maximum. This function is concave up and the slope is 0 there. The reason the first part is very important is, look, this function is what? Concave up. At this point, is that a max or a min? Nothing. In order for it to be a max or min, the first derivative has to be 0 first. Does that make sense? Okay. So we're going to use the second derivative test here. So what is the second derivative? d2y over dx squared equals quotient rule. What's the derivative? Negative 1 times y minus y prime times 3 minus x all over y squared. Now, what is that then? We would say the second derivative evaluated where? Where are we concerned about? When x equals 3 and y equals negative 2. You guys okay with that? What's wrong? You know, at this point, whatever. Now we can eliminate this guy. This doesn't exist. This point is 3, right? So at this point, we either have a max, we have a min, or we have neither. We haven't determined it yet. So we're taking the second derivative to determine the concavity at this point. So what's the coordinate? It's 3 comma negative 2. So we determine concavity by the second derivative. You understood how to get that, right? There's the first derivative. Quotient rule? Okay. So now, what am I going to do here? So it's going to be negative 1 times negative 2 minus, what was y prime?
Negative 2. 0.
It was 0, right? We made it 0. Remember? If you need to figure out y prime, what would you do? Just plug it in here. So what's 3 minus 3? Over negative 2 is 0. So y prime is 0 times 3 minus 3 all over negative 2 squared. So this is going to be 2 over 4, which is 1/2. What does that tell me? It's concave up, right? This is the second derivative, right?
What if it was
Second derivative is positive, therefore it's concave up, which means we have, so we're going to say here's the justification. This is just words. We would say, since dy dx equals 0, and d2y over dx squared equals, or is what? Greater than 0. We would say what? Local minimum. Again, this doesn't always pop up. Most of the time you can figure out max and mins by the first derivative test, but when you have a y involved there, it makes the first derivative test very difficult. Yes? I don't think it's going to ask for that in this case.
what if it
Because there could be other critical points. What?
What happens if it's nothing for Or like, how do you know if it's nothing?
The second derivative would either not exist or it's 0. All right, are we good with that?
Don't reason.
Now that problem, they did it differently on here. And when I read it, it didn't make sense to me. So if you can read that and make sense of it, that's fine. But you should have gotten the first point 3, when x equals 3. That's 1 point. 1 point for identifying local minimum, and 1 point for the justification. So this is the justification, but to get there, you had to do the second derivative. You guys okay with that?
Yeah.
Not really?
Wait. We have to have the answer or no? What if we get the answer wrong? What if we get 4? It's still,
Like this, you mean?
yeah.
Like if it's 4? And you, okay. They'd probably give you 2 out of 3. Why? You got it wrong. You got.
What's the point? What's the
You're
point?
right. You're right. But that's where AP readers get together and go,
Mr. Benny, you should wait.
Well, she was asking if your second derivative ends up being positive, then, well, it's still positive. Yeah, it's like 4. It's still positive, so you get the same answer either way. What if you got negative here?
Justification.
And then you said it's a local maximum because it's negative.
If it was negative, then
No, you would still get 2 out of 3 points probably because based on this, you would have gotten it right. If that, you know what I'm saying? So it's fair both ways. They're not trying to rip you off. It's just they're making sure you know your math.
So if your math is wrong, but your justification is right, they'll give you something.
Possibly. All right. So in that case, your justification was right, but you don't have a local min, you have a local max, so you get justification. All right. Part B. What was dy dx again? 3 minus x over y. Okay, part B was to solve the particular solution, right? There should not be a problem with this one, I hope. Did you guys do this? Honestly, okay, the 6th point at this point might be a little difficult, but the first 5 points should be easy. What's the first step? Separate the variables. So, what are we going to do? Cross multiply, so you get y dy equals 3 minus x dx. So, are we good with that part? So you've earned 1 point so far.
Oh, yeah.
Next point. So there's another point. Equals 3x minus 1/2 x squared plus c. So you got 1 point, and another point. So there's another 3 points. So there's 4 out of 6 points. What?
Is that it?
You can put plus c over here. First of all, if you put plus c and plus c, you might be implying it's the same plus c, same c value. It's not. But irregardless, when I subtract this constant to here, I'm going to end up with some constant. So you don't have to put it on both sides. All right.
Why do they have to make this extra?
From here, what would you do? Initial condition. So we would say what? 1/2 of -4 squared equals 3 times 6 minus 1/2 6 squared plus c. So this ends up being what? 8 equals 18 minus 18 plus c. So c is 8. So there's your 5th point. That should be easy. Here's the hard part.
just move on to the next one.
No. Seriously, this one you have to pay attention to. Okay? The next step is to get y by itself, but before we do that, what do we got to say? 1/2 y squared equals 3x minus 1/2 x squared plus c. And we've got to get y by itself.
Let's see.
Plus 8.
Plus 8, thank you. It wasn't wrong, I just put c instead of 8.
You would have gotten minus 2.
All right. So, all right, multiply by 2 on both sides, you get y squared equals 6x minus x squared plus 16, right? Are we good with this? Okay. Now we are going to square root everything, but this is where everybody has a hard time, and I'll explain why in a second.
It's right, for like the AP test, like, if we just put y equals like square root and then just put that under a square root, is that right?
No, but let me answer why. Okay? How would you solve this? You would square root both sides, right? So y equals the square root of 6x minus x squared plus 16. Watch this. We had an initial condition, right? What was the initial condition? 6 negative 4. Let's plug it in to see if it makes sense. If I plug in 6, 6 times 6 is minus is 0, plus 16 is 16. The square root of 16 is? We were supposed to get negative 4. What happened? Because when I square roots, it could be plus or minus, right? Except in geometry. Okay, now, careful. We don't want to put plus or minus down, though. I did, but I'm making a point. The reason is this. Let's just look at a basic y equals rad x function. The assumption is, what's that look like? Half a parabola like that, right? The assumption when I put rad x, it's the upper part, right? But it could also mean this. The only reason we don't do both is because this is not a function. But is this not true? It's just not a function. Okay? We're dealing with functions. It says g is a function. Okay? Therefore, I want the part, I don't want this part and this part, I want either this or this. I want the one that has the initial condition of 6 comma negative 4. I want the one that has that point in it. So therefore, I want which version? The negative version. So make sure you have the negative out front. Now with all that thinking involved, I'm going to cross that out. With all that thinking involved, once you got C, you got 5 out of the 6 points. It's that, just checking the signs. And that's why the natural log thing, why I say natural log has to have the absolute values. It's the same reason. Okay? Now, keep in mind this. You know how you guys were looking at the slope fields? There's that hyperbola one. The slope field looks something like this.
That's really satisfying with the sun.
Okay, the slope field looks something like that. And you go, what the heck is that, right? Well, wait a minute. It's a hyperbola, which you may not understand, but look. If I'm looking at an initial condition right here, what's the graph going to look like? It's going to look something like that.
Oh, okay.
If it was here, what's it going to look like?
Something like that.
It's going to look something like that, right? If it was here,
Something like that. Oh,
because if I keep going with this hyperbola, it's not a function, right? But here, if I keep going, it's still a function, right? Okay. So depending on where your initial condition lies, you get different kind of curves.
Wait, why is it a function right there?
It would be, I just didn't use it there. Okay. All right. Any questions? So in all reality, this problem, I get the part A, there was a little bit of difficulty because of the second derivative test, but you should have gotten 7 out of 9 on this one. You should have gotten the 2 on part A, and then the 6 points here. Maybe not this. Maybe you got a 6 out of 9. All right. Next one. Let's look at 19. Which one's 19? We're looking at part A. This just says show, and it gives you the answer. You just got to show why it's true. Now notice you look at a cylinder. What is changing as the amount of coffee?
The height.
The height will change? The volume will change? Will the radius change?
No.
No. Okay. If it was a cone, the radius would change, right? Okay, so what's a constant? The radius of 5 is a constant. Now, it says show that dH dt is negative rad h over 5. Here's what it did tell us. It says that the volume is changing at a rate of negative 5 pi over, or negative 5 pi rad h. So what is that? What did you say? V prime, but let's write it in this notation. dV dt is equal to negative 5 pi rad h. You guys okay with that? It gave us that. We just have to put it in the notation that's helpful. So right here it says the volume is changing at a rate of. So dV dt is this. We're trying to show that dH dt is this. What else did it give us? It told us that volume is equal to pi r squared h. Well, what do we know out of this? We know the radius. Is the radius changing? So I can plug it in right now. So we're going to end up with 25 pi h. You guys okay with that? Remember in related rates, we wanted to take the derivative before we plugged anything in. But we could plug in the 5 because it's constant. Okay, so there's dV dt, there's dV, or there's v. Well, this is dV dt, this is v. Take the derivative. So dV dt equals, what's the derivative of that? Right, remember, what's the variable? T. So this is a function, h is a function in respect to t. So the answer is 25 pi h prime or dH dt. You guys okay with that? What can I do with these two things? Set them equal to each other because they're both dV dt's. So negative 5 pi rad h equals 25 pi times dH dt. And our goal is to solve for dH dt. So we just have to divide by 25 pi. So we end up with negative 5 pi rad h over 25 pi equals dH dt. What do you get? Yeah, what do you get? Negative rad h over 5 equals dH dt. And that's exactly what we wanted, right? Yeah. Yeah, on part A it just said show that dH dt is equal.
So is that all of that, or is it just like...
Well, let's see how they scored it, and that'll tell you. You got 1 point for showing that dV dt is written like that. So basically reading what was in the given, and then rewriting it as dV dt. You get 1 point for computing dV dt from here, and then 1 point for basically setting them equal and getting down to that point. Okay, part B. Part B. It says, given h equals 17 when t equals 0, solve the differential equation. That's easy, I hope. Rad h over what? Negative rad h over 5. All right, what do I have to do? No. We're solving this. Separate the variables. So what do we do?
It's okay.
We got to get the h's over here.
Oh, yeah.
So this is going to be 1 over rad h dh equals what? Negative 1 over 5 dt. You guys okay with this? Now, before I go on, is this going to be natural log? No, because what's the exponent on this? 1/2. So I'm going to rewrite this as h to the negative 1/2 dh equals negative 1/5 dt. And then we'll integrate from there. You guys okay? What's the antiderivative of h to the negative 1/2? H to the 1/2. 1 over 1 over 2. 2. And check it with the derivative, right? Multiply 2 times 1/2, you get 1, so we're good there. And then h to the subtract 1, negative 1/2. Wouldn't it be negative? If I put negative there and I do the derivative, it's going to be negative out front. We don't want that. Equals, what's the antiderivative there? Negative 1/5 t plus c. And now we have an initial condition of 0, 17. So it's going to be 2 radical 17 equals negative 1/5 times 0 plus c. So c equals 2 rad 17. Now what?
Isolation.
So we got, no, I'll plug it back in first. So you got 2 rad h equals negative 1/5 t, oops, negative 1/5 t plus 2 rad 17. Now what? Isolate h, so we're going to divide by 2. So we got rad h equals what?
Negative 1/10.
Negative 1/10 t plus rad 17. Now what?
Square root of square.
Square both sides. I saw this on your quiz, some of you. We got h, right? On that side? When I square a number, could I get plus or minus?
Yeah.
No, it's when I square root, right? So this is good right here. Leave it like this. What some of you did on your test is you said, oh, that's negative, or sorry, that's 1 over 100 t squared plus 17. Why? Because you squared this and you squared that, right? What does squaring a sum mean? It means this times itself, so you got to FOIL everything if you're going to simplify it. Carmen's back there smiling real big. Okay? That's it. Okay, let's take a look at how they graded it. This one was only worth 5 points instead of 6. You got 1 point for separating the variables. Okay, you get 1 point for both antiderivatives correct. So this is only 1 point. 1 point for the C, 1 point for using the initial condition, and 1 point for solving for H. Okay? Yes, look at the notes. What's it say? If you don't put plus C, you can't get anything more than 2 out of 5.
If you don't separate the variables, you can't even get it.
Yep, you don't get nothing if you don't separate the variables.
So if you like don't separate the variables,
Worth nothing, that's for sure.
So you get something, right?
Nothing is what you get. All right, C. C says, at what time is the coffee pot empty? How do you know when the coffee pot's empty?
When H is 0.
When H is 0, there's nothing left, right?
You just take that and set it.
Yeah, take that, set equal to 0. So you get 0 equals negative 1 over 10 t plus rad 17 squared.
Is that the only way to do it? So it's like if you got B wrong and you're just going to get C wrong too?
Okay, so this is how you manipulate the system. Oh, I shouldn't have said that. No, seriously, this is how you think around it. If you don't know how to do part B, you're stuck on part C, but don't let that do that to you. You go, okay, if I don't know what the H function is, I'm going to make one up. I'm going to say, let H equal 3t, whatever it is. Then you say, okay, I know the H is supposed to be 0. Obviously, this is, so plus 5. No, that won't work either, because that'll give you negative time. Minus 5, right? So what they see then is what? 5 equals 3t, so t equals what? 5 over 3. What they see is you know what you're doing. You just didn't get to this point, but if you knew that, you'd be okay. So they'd probably give you the point for that.
So what if
I think they'll give, oh, on my test?
Yeah.
No. All right.
I'm going to do it now. Just like,
Solving this, hold on, solving it. We're going to square root both sides just to make it simpler. And then we'll subtract, so we get what? Well, actually, I'm going to add this. So I get 1/10 t equals rad 17. And then we'll multiply by 10. So t equals 10 rad 17. And that's it. So when t equals 10 rad 17, the volume is 0. You only got 1 point for that anyways.